Linux commands. In this nugget, we continue our discussion of basic Linux commands by looking at commands that'll help you find files and executables on your system. Then we'll move on and talk about commands that we can use to manipulate text files or text streams in Linux. So let's get to work. All right, well, our first topic for this nugget is going to be how to use the find command. Now, the find command does probably what you think it does. It finds files on your system. Now, you have to give the find command basically two pieces of information at least. The first piece of information is the starting point. So where do you want find to start looking for these files? Okay, do you want it to start at the top level directory? You could say find slash, and then you can give the search criteria after that. So this would start at the very top of the directory hierarchy and look in all the various subdirectories. All right. Now, in order to do that, you better have the permission so that you can look in those directories. So you should be the root user to carry out a find starting at the top level directory. Okay, but since I'm just logged in as the normal user Perry right now, I could start a search in home Perry and successfully, if I could type here, and successfully search throughout my whole home directory and all the subdirectories of my home directory. Okay. One thing to notice here is that I'm already in my home Perry directory. You can see by my prompt there. And one way to start searching in your current working directory and all the subdirectories of that is you can use a shortcut name, and that just is the dot. All right, so dot always refers to your current working directory. So this says start looking in my current working directory. All right, so once you specify the starting point for the find operation, for the find operation, then what you do is you give the search criteria. Now, the search criteria can be any number of things. You can search for files by name. You can search for files by size, by modification date, and so on. And we'll look in the man pages shortly, and you can see all the different criteria that you can use with find. But for right now, what I want to do is I want to use a simple one, minus name, and then I'm going to give the name of the file that I'm looking for, junk. Okay, so what this says is start looking in my current working directory, which is home Perry, and look for files that have junk in the name. All right, so I'm going to hit enter here, and now find is going to return all of those files. All right, so it found a file, and it's in the miscellaneous directory, and there's a file in there called junk. So dot/miss/junk. That's the location. If it found more than one file, it wouldn't just stop. If there was more than one file named junk, it wouldn't just stop at the first find. It would keep looking through all the various subdirectories of Perry, and it would print out all of the files that had the word junk in it. Okay, so that's sort of the most simple version of how to use find. Now let's take a look at the man page and the info page, and you'll see all the various options that you can use with find. All right, well, let's take a look at this info page for the find command, and here you'll see all the different options and things that you can use with find. So as I tab down here, we'll just skip the introduction because I've sort of already given that to you. Let's go to the finding files subsection, though, and see what's there. So this is all the different kind of search criteria that you can use with the find command. We've already seen how to use name. I showed you that in that example a couple minutes ago. You can also search for like symbolic links. We haven't talked about these yet, but these are links that you create to sort of link up directories across the directory hierarchy. Then you can search for files based on some timestamp. I'm going to hit enter here, and we can look at the different timestamps that are kept track of for files. So you can search for files based on their access time, the time that they were last read. You can also search for files based on their modification time, when they were last changed. And number two here is you can also search for files based on a change of the status of the file. So either the file was modified or one of its attributes was changed, like the permissions on the file was changed, or the ownership of the file was changed, something like that. Okay, so I'm going to hit U here to go back up, and we can go back to where we were. We can also search for files based on their size, the type of the file, the owner of the file, the permissions on the file, the contents of the file. We sort of have already seen how to do this with the grep command, but there are ways to combine grep and find, and you can see examples of that under the contents subdirectory here. You can also restrict the directories that you're going to look for with the find, that the find command is going to use to look for the file that you're looking for. Let me explain. So in directories here, what we can do is we can set, for instance, like a max depth. So say I start at the top level directory in the hierarchy, and I know the file that I'm looking for is somewhere in one of those top level directories. I just don't remember which one. So I can say search, at the top level directory in all of the subdirectories, but go to like a max depth of 2. That way I won't go down some, library subdirectory, and I know it's not deep down in that directory hierarchy. If I know it's up at the top, I can use some restrictions that are in this directory subsection. Okay, so let's go back up again, and we can see the different types of actions that we can take once we find a file. So when we're talking about actions that we can take with the find command, we're talking about doing something to the file that we just found. All right. If we go to the action subsection, you can see the most common things that we'll do to a file once we find it is print the file name or print some information about the file. But we can also run Linux commands on the file that we just found. All right, so let me hit enter here and go to the run command subsection. And the only one of these three that I want to cover is the single file option. Okay, these other two, we're going to have to learn a little bit more Linux to really understand those later on in the series when we get to covering like xargs and things like that, which is a special Linux command. Then we'll be able to understand what these two what we're doing with these two. So let's just cover single file for right now. Okay, so what we have to understand here is that we're running a command on the file that we just found. We do that with the -exec option for find. And as we go down here, we can see what happens is we can specify -exec, and then we specify a command to run on this file that we just found. We specify that file we just found with a single quote surrounding curly braces. Okay, so in this command down here, this right here represents the file that we just found with the find portion of the statement. So let's break down this command. I think we should understand this part. I think we have all the tools to understand that. This says find, starting in the current working directory, files with the name anything.h. Now, if you're not familiar with C programming, these .h files are header files. Okay, they contain things like variable information and constants and things like that you're going to use in your programs. Okay, so we're looking for all the header files starting in our current working directory. All right, good. Now the exec portion of this statement says do a diff. Now the -u option for diff it just has to do with output, and I guess we haven't covered the diff command either, so let me explain what that is. This just looks for differences between two files, and it will print out the differences that it finds line by line. Okay, so the exec portion of this find statement says do a diff on this file that we just found with the find statement and this other file called temp master. Okay, so it'll do that diff between those two, print out the things. The next file that it finds that has a .h extension, it will do a diff between that and temp master and so on. The semicolon sort of terminates this exec statement. Okay, so I could put as many commands in here as I wanted. I just need to terminate them by a semicolon. All right, so this is a really powerful way to use the find command, is once you find all these files, then you can go ahead and execute these commands on them. And the last thing I want to do here in the Find Info page is just point you to this Common Tasks subsection of the Find Info page. And in this Common Tasks subsection, they go through examples of how to use the find command for everyday, very practical situations. All right, they go through how to use the find command to view and edit the contents of the files that you're finding, how to archive the files that you're finding, either put them into a tarball or back up to a tape or something like that, how to clean up files from your system, eliminating duplicates or cleaning up all the files in the temp directory that are so old, sort of things like that. Strange file names. Sometimes when you incorporate or import files from another operating system, the file names will have things like spaces in them. And a lot of people find that very odd to deal with in Linux. They don't really know how to deal with that. And so the strange file names examples here show you how to use a find command that will find file names with those strange characters in them and get rid of those strange characters. You can also fix permissions on files that you're finding or classify files that you're finding. So this is a very useful section to browse if you're trying to use the find command, especially for one of these tasks. The examples in here are going to point you in the right direction and save you a lot of time. Okay, well, since we're on the topic of finding files on your system, I want to show you a few more commands that you can use to locate various files on your system, and the first command is actually called locate. Now what I'll do here is I'll type locate Emacs. This is going to search for every file on the system that contains either the word Emacs in the file name or Emacs in the directory that leads to that file, or so on. Okay, so let me just hit enter here and you can see the kind of things that show up. So here you can see all the things that have Emacs in the directory here. There's Emacs in the file names and so on. All right, and you can see here everything's got Emacs somewhere in this directory or path name or the file name. All right, so seemingly that would be a really long, intensive search to look at every single file on the system and see if Emacs is in that file name or not. All right, but actually the locate command is very quick, and you can see as soon as I hit locate Emacs, results started showing up, and they just scrolled down the screen as fast as we could see. All right, and the reason that the locate command is so quick is because it's not actually searching through the directory hierarchy for files that contain the word Emacs. What it's doing is it's referencing a database that's in the var lib slocate directory, and that database is called slocate.db. Now, the slocate.db database is actually built on a daily basis by a cron job. And if we go into etc/cron.daily, okay, and we go into that directory and do a listing there, you'll see there's a cron job in there called slocate.cron. And that is the cron job that uses the update db command to update that database that I just talked about that's in the var lib slocate directory. All right, and then that database over there in var lib is the database that is used by the locate command, and that is why the locate command is so quick at returning hits like it just did. Okay, so there's one command that you can use to locate more files on your system. Another command that we're going to talk about is which. So the which command, what that does is it looks for executables of files. So if I said which Emacs, that's going to return user bin Emacs. All right. Now, this is helpful for locating binaries. It's also helpful for resolving problems that sometimes come up because of your path environment variable. What which is doing is it's going through your path, okay, which is one of the environment variables that we've talked about already, and it goes through the directories in your path to see which directory first contains an executable called Emacs. Sometimes where this helps resolve is if you're writing personal programs and you're putting them in your own bin directory, like /home/perry/bin. Okay, so if I write some program and I put it in home perry bin, and I happen to name that program like locate or something else that is actually a system command, then when I try to run that command locate, it's going to run some other program because the directory of the system-wide locate program, that directory is actually sort of farther up in my path, and that's what the system is going to run when I type locate. So this helps resolve sometimes which executables are actually being executed when I type them directly at the command line. So when I type Emacs at the command line and I hit enter, the binary that's run is the exact same binary that shows up when I type which Emacs. Okay, so that's a useful command for determining which binaries are being run when you type the actual command name. Now the last command I want to show you is the where is command. And the where is command will look for binaries, it'll look for source files and man pages for various commands. So if I type something like where is Emacs, then what happens is it tells me where all the executables are. User bin Emacs. It tells me where libraries that are necessary for Emacs to run. User lib exec Emacs. It tells me where shared libraries are for the particular executable. User share Emacs. It tells me where the man pages are for Emacs. User share man1 Emacs. Okay, so the where is command kind of gives you a summary for a particular command where all the various pieces of that command lie. Okay, and unlike locate, it sort of gives it to you in a very sort of concise format, whereas locate would show you every file under user share Emacs, you know, each one of those files scrolled by on the screen. This is, in my opinion, a little bit more useful for just narrowing down where all the various pieces of a particular command lie. All right, well now I want to move on and talk a little bit about some commands that we can use to manipulate text in Linux. What we'll do first is we'll use these commands on some example text files that I've created in the subdirectory of my home directory called text files, and we'll look and see what some of these example text files that I created are in a second. And then once we learn how to use some of these text commands on these text files, then I'll show you how to use them in pipes and use them when you're piping Linux commands into other Linux commands. Okay, so first let's take a look at this NCAA.txt file. So this is a list of just some of the basketball teams that were in the NCAA tournament. And if we print out that list to the screen, you can see here there's the whole list that I've typed in. So that's not all the teams in the tournament, that's just some of them. Okay, so now what I want to do is show you how to use the command called sort. So now what we can do is we can either just say sort ncaa.txt, and then what's going to happen when I say sort ncaa.txt is it's going to print out the list in alphabetical order. Okay, so that's the sorting criteria that it used. If there were numbers in this list, then it would do, by numbers and so on. Okay, but since all these entries in this text file were words, then it just sorts them in alphabetical order. All right, so we can see that. But what has not happened here is the text file actually hasn't changed. If I print out ncaa.txt to the screen again with the cat command, you'll see it's in just the original order, okay, all jumbled up. All right, but when I use that with the sort command, then it prints it out to the screen in the correct order, but it doesn't change the actual text file. Now, one thing that you can do is you can also say something like this. You can say cat ncaa.txt, okay? Then you can pipe that through sort. All right, so that's going to have the same effect as saying sort ncaa.txt, and if I type that, you can see the result is exactly the same. Again, the text file itself hasn't changed. Okay, using the up arrow to go back here in our history, what I could do here is I could redirect the output of this to some file like ncaa underscore sort.txt. Okay, so now by using this redirection operator, the output of the sort command, which is this sorted list that we see on the screen, will be this file called ncaa sort.txt. Okay, so if I hit enter here, nothing comes up to the screen because the output has been redirected to this file. And if we cat that file, ncaa underscore sort.txt, oops, if I spell it right, okay, and we print that out to the screen, then that is the sorted list. Okay, so that's one way to change a file and change it into a file that is in sorted order. Okay, there are also options for the sort command, and if we look at the info page for sort, you'll see if we go down here, there's a file, an OF qualifier, an OF option that we can use, or a -O option, I'm sorry, that you can specify the output file. Okay, so I could say sort ncaa.txt, and then I could say -O ncaa sort.txt. That's another way to do it. So all those things that I just showed you are just, lots of different ways to do basically the same thing. It just depends whether you want to write the changes out to a file or whether you just want to see them on the screen. Another useful command to know is the NL command. That has to do with numbering lines. So if I say NL ncaa.txt, it will print out line numbers in front of each line. Okay, so this tells us that there's 17 lines in that file, and it just prints it out. So maybe this will help you keep track of something. Again, you could redirect this output to a file with the greater than sign, and then redirect that output to a file instead of just printing it out to the screen. Okay, if you want to save the file with all the line numbers in it. All right. Another another command is the WC command, which is a word count command. And there, if we run this on the file, you're going to see a few different numbers here for output. And basically what these numbers are, it says 17, 22, 178 for ncaa.txt. So 17 has to do with the number of lines. 22 is the number of unique words in the file. So that's why it's WC is for word count. So the things that count as words is like here, like St. Joseph's, that counts as 2 words, or Mississippi State, that's 2 words, Oklahoma State, and so on. Okay, but this thing here, like Alabama, Birmingham, hyphenated, is just 1 word. Okay, so that's why there's 22 unique words in the file, and then there's 178 bytes in the file. All right, and it's just the ncaa.txt is just the file name. It's just reiterating what the file name is that we did the word count statistics on. Okay, so that's another useful piece of information. You can run word count on things like log files to see how many lines of entries are in a particular log file, things like that. Another useful command is the TAC command, which reverses the order of some file. So if I said TAC ncaa.txt, then what this is going to do is print it out in reverse order. Not reverse sorted order, but just reverse of the way that it was before it was sorted. So here's the list here, ncaa.txt, in unsorted order. When I say TAC for TAC ncaa.txt, that reverses it, so it'll print out Dayton first, Xavier second, Nevada third, and so on. So I'll hit enter there, and you can see the way it gets printed out to the screen there. Again, this is useful for things that are sort of in dated order, where the newest entries are at the bottom of the list. If you want to see those newest entries at the top of the list, you print out the list with the TAC command, and that will print it out in reverse order. Now, what does TAC stand for? Well, notice it's cat backwards, right? So cat prints out the list in forward order, TAC prints it out in backwards order. Okay, so that's another useful command to have in your bag of tricks. Well, now let's take a look at this file that I created called test scores. And this is a tab-separated list of student name followed by a score for test 1, a score for test 2, and a score for test 3. Okay, and each separator here is a tab. All right, now what we can do is if we want to extract information from this file, say we just want to see what everyone's second test score is sort of all by itself, we can use the cut command and we can say take out the third field in this file called test scores. Now it's the third field because the first field is the name, the second field is test score 1, and the third field is the second test score. Okay, so if we hit enter here, we'll see just that column of the test score for the second test. All right, now just say we want to see the names paired with these test scores, but we don't want any of the other stuff that's in that file. So let me use the up arrow to go back and edit this command, and the way that I can do this is say 1, 3. Okay, so the -F here in the cut command is telling us which field to pull out of here, and it's assuming a tab delimited file. Okay, so and if I hit enter here, now we can see it says Alice 87, Bill 77, and so on. All right, so this is a way, the cut command is a way that we can extract information from a tab delimited file. If the file's not tab delimited, then if we look in the man page for cut, you'll see down here there is a D, a -D option, and that specifies the delimiter. So if you have some delimiter in there other than the tab, like a colon or a hyphen or something like that, you can say -D followed by a colon, and that will separate out that list based on colons instead of tabs. One common file in the system that uses colons for a delimiter is the etsy password file. And if I just print that out to the screen, you can see how colons delimit all the various fields in the file. The first field is the username. The second field is an X if the password is stored in Etsy Shadow in an encrypted fashion. The third is the user ID. The fourth is the group ID. So just say I wanted to print out all the accounts on the system, the account names followed by their user identification number, I could do something like this. I could say cat Etsy password and pipe that through a cut -D colon, which says the delimiter is the colon, and then I say -F1, 3, and that will pull out the first field, which is the name, and the third field, which is the user identification number. Okay, now if I hit enter here, all of those will come up to the screen, and you can see we're just looking at the first and third fields of that file. So cut is a nice way to sort of pare down and just look at the important information. All right, and if all the other information in that file is extraneous and you're trying to sort through to find some small piece of data, then you can use the cut command to sort of pare down all of that useless information and just look at the most important stuff. Well, the cousin of the cut command is a command called paste. Okay, and you know how to cut and paste text from files and web pages and things like that. This stuff is a little bit different than that. Okay, before I show you how to use the paste command, let me just show you a couple files that I created called animal.txt and food.txt. And these are just alphabetized lists of various animals and foods. Okay, now to use the paste command, the lists don't have to be alphabetized. I'm just doing that for demonstration purposes. Okay, so what we're going to do here is we're going to use the paste command to join these two files together. Okay, and the way that I'm going to use the paste command is sort of in its simplest form possible. I'm just going to say paste animal.txt to food.txt. Now what this command is going to do is it's going to take the first line of animal.txt, put that together with the first line of food.txt, and those two lines together will be the first line of the output. The second line of the output will be composed of the second line of animal.txt and the second line of food.txt. Okay, so it's pasting the files together sort of on a line by line basis. All right, so if I hit enter here, you'll see now it says ant, apple, bear, banana, cougar, corn, and so on. Okay, so there is the resulting output from pasting those two files together. And this is kind of a nice command, right? If you did want to join these two files in this way that you can see right here, in an editor, it wouldn't be, like one keystroke to do that. You'd have to, cut this line, paste it to there, cut this one, paste it on the end of this one, and so on. And that would be a little bit harder, whereas this command saves you a lot of keystrokes if you are trying to put the two files together in this fashion. Now, the other way that you can put two files together with the paste command is with the -s option, which stands for serial. So what this says is put all of one file in the output before you put any of the other file in. So here, if I say paste animal.txt and food.txt together, what's going to happen is all the animals are going to be on the first line of the output and all the foods are going to be on the second line of the output. So if I hit enter, you can see exactly what happens there. Okay, all the animals are first, all the foods are second. Okay, so that's another way that you can paste files together. Now, just like cut, paste assumes that the uses as the default delimiter a tab. So when it's putting these files together, putting these lines together and so on, it separates the lines by a tab, or in the serial case, it separates each line of the file, again, from the next line by a tab. If you want to change that delimiter, you can use a -d again, and I can put in a colon, for instance, and then I can say, let me just use the -s option again, just so we can see the difference right up here. And if I hit enter now, you can see that this output is just like this one above, except the delimiter here is colon instead of tab. Okay, so the paste command is a nice way. It'll save you some keystrokes if you are trying to put files together in this particular kind of way. All right, the next command I want to show you is the FMT command for format. Okay, so before I show you that command, let me just show you this file that I've created called getty.txt. So this is just a piece of the Gettysburg Address. Okay, and what I've done here is I've put in, sort of crazy amounts of spaces between words and new line characters and things like that. Okay, so I've taken the regular text from the document, kept it in paragraph form, but just added all this garbage. I put spaces before and after commas and between words and so on. Okay, so it's become somewhat unreadable, right? And this happens sometimes when you cut and paste text from like a web page or something. And format, if you give it the -u option to do uniform spacing, and then I can type getty.txt there. Let me pipe that through more so that we can see every bit of this file. What that will do is that will uniformly space the file. It'll put one space in between words. It'll put two spaces after periods and things like that. Okay, so that's what has happened to this file, and now the file is in a much more readable format than it was when we started, before we ran the format command. Again, this does not actually change the file. If I look at getty.txt again, you'll see all those crazy spaces are in there all over the place. So the format command just changes it to print it out to the screen. So it writes the result to standard output or to the screen, whereas if you want to change the file itself, then you need to do the format command like this, and then pipe that into, getty format.txt. Okay, so if I do that, nothing will come up on the screen, but if I print out with the more command, getty format.txt, then I hit enter, now you can see everything is formatted just like it was on the screen a little while ago, but we did save all those changes now to this file called getty format. Okay, so there's another command to have in your bag of tricks. All right, well, it's time to wrap up this nugget where we talked about some more Linux commands. We started by talking about the find command, which helps you find files on your system by all sorts of various criteria. Then we talked about the locate, which, and where is commands, which help you find executables on your system and locate files with any sort of string or word in the file name or the directory name. Remember, locate works very quickly because it works off of a database that's updated daily by a cron job. And then we talked about a bunch of commands that help you manipulate text in Linux. And remember, so many things are text-based in Linux. So any output to the screen is a text-based output that you can pipe through these commands to do things to that output, either sort the output or cut out various fields of the output, look for how many words are in the output, that sort of thing. So remember, we talked about the sort command, which sorted output, the cut and paste commands, which are sort of cousins of each other, which either cut various fields out of some file or they paste together files in particular ways. We talked about NL, which is the line numbering utility, WC for counting words and sizes of files, number of lines in files, things like that. Remember, TAC was sort of the opposite of the cat command. It printed out files backwards, which is useful for certain things. And we talked about the format command, so we can format text in uniform ways. There's other things that you can do with the format command, and you can check those out in the man pages if you're so inclined. All right, well, thanks for watching this nugget, and I hope you found this informative.